Welcome to lesson 4. We're going to talk about isotopes today. There's 2 learning objectives. We're going to understand how you find the atomic mass unit. And then we're also going to identify and define what isotopes are. So let's go ahead and we'll need a calculator today for the lesson, so make sure you have one handy. Let's dive right in. And my goal is to move a little bit faster than in my classes. So first of all, we'll identify what an isotope is. Isotope is an element that has atoms of the same element, different mass numbers. So it's the same atomic number. Same atomic number, different mass numbers. So same number of protons, but different number of neutrons. And that's all there is to it. That is what an isotope is. So it's the same element. You might need more lines to write it in. Obviously, typing it's a little bit easier. Let's take a look at some more common isotopes that we use. And the first one is carbon. Carbon has 3 main isotopes: carbon-12, carbon-13, and carbon-14. And each one, it's not too hard. You can tell that all of them will have the same number of protons because it's the same element. It has 6 protons here, 6 protons there, 6 protons there. The number of neutrons is that changes. We know that it has a mass number of 12. Remember, that is the mass. So if it has a mass of 12, it means the protons and the neutrons must add up. In a neutral, it's not an ion, so it has exactly the same number of electrons as protons. Let's take a look at this next isotope. Definitely has 6 protons because that identifies it as carbon, but it must have 7 neutrons because 6 plus 7 equals 13, and it's always the neutrons plus the protons that add up to the mass number. Now the electrons are a charged particle that cancels protons, so it also has 6 without a charge. Same thing here, 6 protons, this time 8 neutrons and 6 electrons. Easy way to do this is just to take the mass number minus the number of protons. That will equal the number of neutrons if you ever get larger elements. All right, let's take a look at over here at a larger element. Uranium 238 and 240. So this is radioactive stuff. We're going to have number of protons. So you just have to look up uranium. We know its mass number is 238. So the protons and the neutrons add up there. And we use my and uranium is down on the bottom row of the actinoid series. You see the comment, you see U right there, and it's element 92. So we know we have 92 protons. And then to find the number of neutrons, we take 238, the mass number, minus the number of protons. So 238, zoom over here, maybe make it a little clearer. 238 minus 92, the atomic number 146. And that's why this, oh, my bad right here, 146. And then the number of electrons always matches the number of neutrons, which is 92. All right, same idea for this one. It's still uranium, so it's still 92. In this case, we take 240 and minus 92. And we get 148 neutrons. And the number of electrons equals the number of protons in a neutral atom. So different isotopes of the same element must contain the same number of, well, different isotopes of the same element must contain the same number of protons. two different isotopes of the same element must contain different numbers of neutrons. Isotopes of a given element have the same mass number? No. Have the same atomic number? Yes. Different mass number? Yes. So it's option B. All right, let's move on to the next page. We're going to calculate the atomic mass for any element. And the way you do that is you take the weighted average of an element's naturally occurring isotope. So let's say if it's 10% and its mass is 100, we multiply those up, and then that will give us our weighted mass. And then we'll do one with you, and let's take a look at this first one. Now I'll do this example once or twice, and then I'll give you some practice problems in the notes. All right, the first one, the exact mass of each isotope is given to you. Chlorine has two naturally occurring isotopes, chlorine 35 and chlorine 37. They give you the mass here for each of those. And this atmosphere, 32% of the chlorine is 37, and 67% about is chlorine 35. What is the atomic mass of atmospheric chlorine? All right, so multiply the mass of each separate isotope by its percent abundance. There's a little math thing that you'll need to be able to be fluent in. That's to be able to convert percents into decimals. So when we have 32.51%, you'll have to know that equates to a decimal of I'll write it over here across the line, 0.3251. So make sure you're very comfortable and can fluently translate percents to decimal. All right, multiply the mass. So let's take the mass of the first one. It's Cl35. The mass number is 34.9689. And what we're going to do is multiply by its percent abundance. It's for chlorine 35. The percent abundance is 67.49. So I'm going to convert that to decimal, 0.6749. And then for chlorine 37, its mass is 36.9. Looks like I wrote 36.959659. And its percent abundance, I should highlight these numbers for you. This chlorine 37 is 32. Try not to get confused with all the numbers. You just need to find out which one is labeled. They might not be labeled in the same order like in this problem. Okay, once we have this, what we're going to do is multiply those out and then add them together. And this is where you need to show work. Okay, I can give a lot of advice, but if you don't follow this advice, it will become twice as hard, because you won't be able to account for all the different work. So in our calculator, I can make this a larger screen. I don't think it's that hard. Just going to take 34.9689 times 0.6719. 23.6, blah, blah, blah. Zero, 5. And the next one is 36.9659 times 32%, which is 0.3251. Weighted average is 12.0176. And then we're going to add those two numbers. And I get 35.6181. And I'll look at my significant digits. I see I have 4 significant digits here. but I have 6 significant digits here. I can be no more accurate than 4 significant digits. So my weighted average will be 35.62 AMU, atomic mass units. All right, and this is my atomic, this add up the products, or I just did that right there. That's my average atomic mass. Okay. Well, because it's addition, actually, you don't have to round it. It should be 35.6181 AMU. Because these are each out to the, these are fine. All right. This is your average atomic mass. If you get that exact, you're fine. All right, let's take a look at another example. We have carbon 12 and carbon 13 with the percents found. These aren't exact masses, but they're close. Multiply the form, so I think you're getting the idea. I like to write carbon 12 over here, carbon 13, to keep my line straight. I first write down their mass numbers. And since use 12 and 13 for the mass numbers. So in this case, I'm going to have carbon 12 is 12, and then multiply by its percent, which is the predominant one, 90%. Then we have carbon 13 multiplied by its percent. But remember to move over its decimal once. And that's all there is to that. 0.989 13 times 0, 0, 0, 1, 1, 1. And then add these together. And we get 12.011. And hopefully you got that. By the way, each individual of these is 11.86668. And this one was simply 0.1443. All right, those are the two numbers I added. I'll keep it out to 4 sig figs here or beyond the decimal. All right, let's take a look at one more. Calculate the, actually, I'd like you to try this one. You can pause the video, try this one yourself. If you need practice, go back to the earlier part of the video. Okay, hopefully you paused the video and did it. The answer to this one is 10.8 AMU. If you have any questions, go back to the previous examples, the same idea. All right, what if there's 3? 3 doesn't make it any harder. You just do the same weight. Make sure you remember that this number here is the mass number. All right, let me just get that working. That's the mass number, that's the mass number, that's the mass number. So I might set this one up for you. So you're just going to say it's 1 times 99% plus 2 times 0.6. Oh, that's not correct. To change that to a percent, we need to go actually farther out. And this has a mass number of 3, and it's only 0.4%. So it's 0.004. All right, that's the setup for this one. Add all of those numbers up. Try that now. I'll pause the video. All right, hopefully you did it. Unpause the video. Your answer should be 1.01 AMU. All right. So what is the mass number? Remember, it's the mass of one isotope. Okay, and they have to give it to you, or you just assume it by what its label is. The atomic mass, though, is a little bit different. It's the average mass of all the isotopes of a given element. All right, and that concludes our notes for today. I think you probably remember what your homework is. but just to go over it. Your homework is, we finished 12 through 15 in the note packet. Your homework is 11 through 14 in the practice packet. Pretty much, I think the same, so I won't go in over the practice packet here, but in the class. All right, guys, thanks very much. Have a great day. And see you later.